Hi guys, I want to just take a quick minute today to clear up some things about when we're reflecting over lines that aren't the axes. Obviously the rules for that are very simple, but for instance when we have a point here, I'll call that point A, and I want to reflect it, let's say, over the x-axis down here. Okay, the reason that we're able to just count down that that's 2 units and then count 2 more to say, okay, my A prime is going to be right here, is because it all boils down to that traveling perpendicularly. And so since my x-axis is a horizontal line, I know that to travel perpendicular to that means to travel straight up and down. And that's why it's so simple in this situation. But if I go on to a slightly more complicated one, like the line y equals x minus 1, it's a little less clear. So let's say, for instance, here we have point A at 3, 0, and I have another point B at negative 2, 2. Okay? I want to make sure I'm clear about what's happening here. It all goes back to traveling at a perpendicular direction. And we can use our knowledge of slope, like we talked about the other day, to help us with this. So, for instance, the slope of this line, my mirror right here, the slope is 1, which means to travel perpendicular to that, the slope has to be the opposite reciprocal, so I need to travel with a slope of negative 1. Okay? So what that means is, if I'm at A and I want to reflect over this line, I need to be traveling along a slope of negative 1 to be moving perpendicular to my line of reflection. Okay, so in this case, this distance is across one little square, which means if I go in that same direction with the same slope by the same distance, here's where my A prime is going to land. And so my A prime is going to be the point 1, 2. I can use the same logic for B. Right, I'm traveling with the slope of negative 1, so since the line is below me, I need to be going down 1 and right 1. Down 1, right 1. And I'm going to keep traveling along this line, right? And I just need to make sure that I keep the same distance. So in this case, my distance that I've traveled is across 2 of these squares, and half of one more. So here's the half and there's 2 more. So now I know that B prime is going to be at this point 3, negative 3. Okay, so it's all about traveling perpendicularly. If I wanted to reflect over a line that had a slope of 2, then I would need to travel up 1 and over 2 at negative 1/2 in order to move perpendicular to that line of reflection. Let's look at one more example. This time we have a line y equals 2 minus x, which means my slope right here is negative 1, not 1. So for each one of these points, I need to travel with a slope of positive 1 to reflect. So my point J, I need to travel at a slope of positive 1, which is going to put me right up here with the same distance. And so my J prime is equal to the point negative 1, 6. That's J prime. Right? My K, again, traveling with the slope of positive 1, is going to land right here. There's my K prime. And L prime, slope of positive 1, up 1 over 1, is going to land right here. That's L prime. Sorry, I should have written these over here. So that's going to be 5, negative 1. And K prime was negative 2, 2. All right? And so you can see, I'll pick a different color to actually draw this triangle, but so here's our triangle, J prime, K prime, L prime, that's been reflected over this line of reflection right here, y equals 2 minus x. So I hope that clears up just how I'm deciding how to travel exactly, precisely. But I also think it's worth it for us to talk about, what about writing the rule for what's happening in the situation? And anytime we have a line that's not one of the ones that you've memorized, right? Like, so we've talked about like reflecting over y equals x or y equals negative x or one of the axes, and that seems all fine and good, but it's a little harder when it's not one that I've memorized. But what we want to compare it to is one that I have memorized. Okay, so for instance, when I look at this particular line of reflection, it looks really similar to y equals x, right? And so I'm going to use that as a base. My rule for y equals x reflection is that it takes some point xy and it makes the coordinates switch to y comma x instead of x comma y. So what I want to do is, keeping that in mind, put some random points down, see how they get reflected, where they land, and see if that can help us come up with the rule. So I'm just going to jot down some random points to start. Alright, so I've got points A, B, and C here, and their coordinates, and I want to know where will they land if I reflect over this line. And obviously this line that I have has a slope of 1, so I'm going to be traveling with the slope of -1. So if I start at A and go down 1 over 1, I do that 2 times to get to the line of reflection. So if I do it 2 more times, I land right here at the point 0, -5. 0, -5. B, when I reflect it, will land right here. So B prime will be the point 3, 4. And C prime, again, that's now I'm going down 2 over 2, so I'm going to have to go down 2 over 2. That makes sure that my slope is correct. And so C prime ends up being 3, -2. So what we want to do at this point is compare my original points here to my image points over here and see if I can recognize a pattern. Now, just looking at these numbers, it doesn't seem like there is one, but that's where it goes back to me using this as a base. I know that what should happen if I reflect over the line y equals x is that it should switch the coordinates. So if I start off with that in mind, let's see if that can help us. So for instance, I'm personally going to just take these points and say, what would happen if I did just use the old rule? If I just switched them, -4, -1 would turn into -1, -4, right? The B would be 2, 5, and the C would be 2, -1. And so then I'm going to try to see if there's any correlation between what would have been my A prime to what really is my A prime, and compare that to how B prime is different and C prime is different. And so as I'm looking for a pattern, I might notice, hey, 0 is 1 more than -1. 3 is 1 more than 2. And 3 is 1 more than 2. So it seems like instead of just switching the x and the y, it's like I switch the x and y, and then I add 1 to that, to what I get when I switch, right? So I switched it, got -1, added 1, and got 0. I switched the coordinates, and so 2 became my x right here, and then I add 1 and I get 3, and so on. And so then I can look at the same thing with the y coordinates, right? So -4 turned into -5. 5 turned into 4. -1 turned into -2. So this number is 1 less than this number every time. So it's just like my x coordinate, but I'm subtracting 1 each time. So in this case, notice that the coordinates are switching like I would expect when I reflect over the line y equals x, and then it has something to do with the +1 or -1, because let's go back to this original equation, right? We had this line y equals x minus 1. So it makes sense that it's similar but not the same as y equals x, and that the difference has to do with adding or subtracting 1, because that's how much that my line of reflection has been moved. It's down 1 from my original one. And so hopefully that gives you some insight. I'm going to do it one more time with the horizontal line. So this time I have y equals -1. Pick some random point. Okay, so here I have A, B, and C. I'm reflecting over this line y equals -1, which is really similar to the x-axis, right? So remember, when I reflect over the x-axis, our rule was that the x-coordinate stayed the exact same, but my y changed sign. So, keeping that in mind, let's see what will happen. When I reflect A, it's going to go down 2 below, so A prime is -3, -3. B prime will land up here at 0, 0. C prime is going to go up 4 units, so up 4 from there is 1, 2, 3, 4, 5, comma 3. So it makes sense so far that my rule is related to this because none of these x coordinates changed. 0 is still 0, 5 was still 5, negative 3 was still negative 3. So my actual rule appears to be x comma something. Now, if I just change the sign of my y, this one would be negative 1, but it's 2 less than that. This one would be positive 2, but 0 is 2 less than that. Negative 5 would be positive 5, but 3 is 2 less than that. So it appears that it's not just change the sign of the y-coordinate, it's change the sign and subtract 2. Okay? I'm going to let us play around with this a little more tomorrow in class, but I think we can understand why it's a 2 and not a 1, because that's a little surprising, but there's a reason for it. I hope this makes sense, and obviously you may have some questions, but we'll clear it all up tomorrow. Thanks a lot.